Okay, Algebra 1, 7.3, Part 2. What we're going to do today is we're going to solve equations that have exponents. And so there are a couple different ways to do these. And my biggest thing is my rules is number one, get common base. Actually, if we want to, we get into the fact that you will see this again next year. You will see this again in geotrig, and you'll see this again in pre-calc. This usually is in the same section as logarithms. And we're not doing logarithms, so don't get scared about that. But it's a different way of solving. Right now, our exponent has the variable. And so my biggest thing is if you can get common bases, if the bases are the same, that means your exponents have to be the same. So then you can set exponents, equal. Not a good one there. Set exponents equal, so solve it. So what we have here is 8 to the x equals 4,096. So you got to kind of think. 8 is a base. Some power, x, is equal to 4,096. The question you need to ask yourself is, does 4,096 happen to be a power of 8? Can I write that as 8 to some power and it will equal 4,096? Take your calculator out. 8 to the first power is 8 to the first power is 8. 8 to the second power is 64. That's not it. 8 to the third power? Take your calculators, people. What's 8 to the third power? So 512? That's not it. How about 8 to the fourth amendment? 4,096. So wait, these are equivalent things? 8 to the fourth power and 4,096? I can interchange them. 4 quarters for $1. You're okay, right? So that still would be equal to 8 to the x, yes? Wait a minute. Wait. If these numbers have to be the same, it means everything about them has to be the same. We made the 8s, or the bases, the same. That means, what about the exponents? They have to be the same. So it means x is equal to 4. Done. It's not so bad, is it? How can you check it? Put 4 in for x. 8 to the fourth power is 4,096. It should work. That's the wonderful thing about equations, is you can always check your work. And then maybe step 3, if you want, put check. I mean, that's a given, but some people don't do that. Next problem. That's a really bad exponent placement. Maybe I'll fix this. What I have here on this one is 3 to the power of 3x plus 1 is equal to 81. 3 is a pretty basic number. So I'm not going to change 3, but can I change 81 to be on a power of 3? So you kind of, again, go through your checklist. Can I change this to say 3 to some power? 3 to what power is 81? 4. Oh, 4 again. It's not always going to be 4. It happens to be 4 in this one. If those numbers are the same, that means the bases are the same and the exponents are the same. So when does 3x plus 1 equal 4? Can you solve that?
Minus 1 divided by 3.
Subtract 1, subtract 1. 3x equals 3. Divide by 3. X equals
1.
1. And your answer is 1. Again, check it. 3 times 1 plus 1 is 4. 3 to the 4th power is 81. Okay, one more problem. Now we have 4 to the x minus 3 equals 32. Same idea. Get a common base. Here's the problem. The last problem's 8 to the 4th power was 4,096. 3 to the 4th power ended up being 81. 4 to what power is 32? You can't. 4, 16, 64. So I jump right over the fact that 32 is in the middle there. Or 32. So that means I cannot use 4 as a base. So we got to step back and say, wait a minute. 4 and 32 are exponents or powers on what common number? What's what? 2. So I'm not going to change just one of them. I'm going to change both of them. I need to change this to say 2 to some power with an x minus 3 and 2 to some power. 4 is 2. 4 is 2. 4 is 2 to what power?
2.
2. 2 squared. 32 is 2 to the? Not 16. Wow. That's a very large number. 2, 4, 8, 16, 32. 5.
16.
So what we have here, guys, is I just exchanged 4 for 2 squared, because that's equivalent, and 32 with 2 to the 5th power, because they are the same. We now have a common base. Yes?
No.
Now we can solve it. But here's the thing. I have a power of a power. Do you guys see that? I have a power of a power going on here. I need to get rid of that power of a power. And a power of a power, for here, you multiply. Here's the thing. That's a monomial, single thing, times a binomial, two things. What needs to happen? Rainbow, yeah. Or distribute. What's really going to happen is it'll be 2 times x minus 3 equals 2 to the 5th. Okay? So be very careful on that. So that, therefore, we can say, hey, these have to be equal for the numbers to be the same. 2 times x minus 3 equals 5. I could care less about the bases now because they got them common. And so, distributing 2x minus 6 equals 5?
Yep.
Right? Distributing the 2.
Yeah.
Add.
Now I can add 6. And I end up with 2x equals 11. And divide both sides by
2.
to get 11 halves. Or, if you want, 5.5.